apparently you'll need some help understanding a little bit more about what the joule is, and that's totally fine. The joule itself is simply a measurement of heat and energy. Heat and energy. It's very simple. Now, there is a fancy description to this whole thing, and I will elaborate on it just to give you some sort of idea of what the official definition is. This is, the joule is exactly what's called 1 Newton, and that's named after Sir Isaac Newton. 1 Newton of force placed over 1 meter of length. And I know it sounds rather bizarre, but 1 Newton of force over the distance of 1 meter. There's another way to describe it, and that would be like the use of the term like watts. For example, you've probably heard that your microwave is 1200 watts, or your hairdryer is 800 watts, or something along those lines, or a 60-watt light bulb. So in this case, a joule can also be defined as 1 watt of power, and that's exhausted over 1 second. So there's sort of ability here to define what one unit is using other units to give you an idea of what it is exactly that that type of force is. Now, let me give you a couple of other examples of what a joule is. For example, if you have, let's say, a 2-liter bottle of soda, and this is a very poorly written 2-liter bottle. So let's say it's 3/4 full with soda. The area, the amount of pressure exerted by the carbon dioxide gas in that 2-liter bottle of soda, the pressure on the outside container, that is exactly 1 joule of force. For example, we can also say that if you had a 1, say, square decimeter, and that's 1/10 of a meter, so it's like 10 centimeters. If you had a 10 centimeter square piece of surface and the sunlight was coming down on it, then that right there would be 1 joule of energy. Think of it like this. You can think of it this way too. How do? By clicking on what you did, you're now accessing the math help section. In this case, you're asking, how can I compare two different things? In this case, we're looking at kilojoules, amounts of energy. And we're looking at a very big amount of energy, as the Yellowstone Caldera is, when it exploded and stuff, it could create, and a rather unverified number, of 478 terajoules of energy to rip up that entire area and send all that mud and ash and dirt and volcanic whatnot up into the airs. So, now your job is to make a comparison. Now, I'm going to show you the mathematications to make this happen. Okay, so when you're going to draw a comparison, the first most important thing is that you have to make sure, and I'm going to draw this out because it is so very important, you must make sure that the units that these items are compared in are the same. If they are different, you are going to end up sad because your numbers will be jacked up. So, if we're looking to figure out how this is done, let's do an example. Okay, now, when doing a comparison, and we'll write that, a comparison. In this case, we want the comparison to give you indications of how much one thing is bigger than the other. So what we'll do is we're going to make one, we're going to put the big one on the top. So you put the big number on the top. Now in this case, nothing's going to be bigger than the Caldera. So in every case, inside the numerator, which is on the top part right there, you're going to put the Caldera value. So it will be 478 terajoules. Now, let's take a look at that first one. How many times bigger is the Caldera explosion than, let's take a look at number 1 as an example, than a falling brick? Now, according to this, a falling brick has the amount of energy, it's about 66.5 kilojoules. Now, you'll notice something. Kilo and tera, they are not the same. So we're going to have to do something here to make them the same. So we can either divide this by the appropriate conversion factor. And I know that's a big fancy word, but that basically means is we're going to multiply it by how many terajoules are in a kilojoule or vice versa. Now, in a previous video, if you happen to watch it, you look like there's a significant conversion factor between these tera, and kilo. For example, kilo is 1,000 times smaller than mega. And a mega is 1,000 times smaller than a giga. And a giga was 1,000 times smaller than tera. So what we can do here is we can multiply tera by the same number of zeros that gets us down to kilo. So in this case, there's, let's see, what it looks like 9 zeros. So that's about 1 billion. So in this case, we're going to put, there are 1 billion kilojoules in 1 terajoule. Now, if you know anything about algebra, you'll know that when you're multiplying stuff and there's things that are opposite each other, you can cancel them out. That's the hint that you're doing this right. So now, if we multiply across the top, you get 66.5 terajoules, put the T in there, divided by however many terajoules, actually it's 0, 0, and a whole bunch of zeros, 9 zeros. So now what we're going to do is we're going to do the math. So we got 66.5 divided by 4, 5, 6, 7, 8, 9. I just typed in 9 zeros. Okay, so now we're going to hit equals, and that's going to provide us with a really small number, 0.1234567 terajoules. That should be a T, terajoules. Now that we have the units that are the same, now we can compare them. So if we put 478 in the numerator, terajoules, divided by 0.0, and there's a whole bunch of zeros. Here's like what, 3, 6, 7 zeros. So it says 0, 1, 2, 5, 6, 7 zeros, and then 665 terajoules. Now we can do the division and figure out how many brick drops would equal a Caldera explosion. This is going to get ridiculous. Okay, 478 divided by 0.12345676665. Okay, here we go. Holy Mary Moses. Okay, that's going to be the equivalent of 7. And I'm just going to write numbers down until I figure out what it is. 96994.8. Okay, that's just ridiculousness. So that's approximately 7 trillion. So let's see if we can round this. So let's say 7.2 trillion brick drops. Trillion. I don't know. It's just, I'm dumbfounded. That's just so many. So now I've drawn a comparison between falling bricks and the biggest volcano on the planet. So it would be the equivalent of dropping 7.2 billion bricks. That's a lot of bricks dropping all at the same time. It's kind of crazy. Now, so you've seen what happens when we've got units that are different. We got to make them the same. And you might have to use a conversion chart to be able to make that happen. So, now that you have an example and what to do, tell you what, why don't you go try some of these on your own. If you get stuck again, you can always rewatch the video or ask that Temple guy. You know, I think he knows.